Hello, in this video, we're going to use the definition of the derivative to find the derivative at this given point. What we first have to recall is that the definition is that the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's what we need to do. First, we'll write out our f of x. Then let's write out our f of x plus h underneath and recall what that means. That means everywhere I see an x, I have to now put an x plus h. So that's all that we're going to do. And then we're going to replace it into our equation. So we have 1 over x plus h minus 1 over x all over h. The limit as h approaches 0. So the next thing we're going to do is clean up the top. And I'm going to take it separately to the side. We're going to take the numerator. And we're going to clean this up and plug it back in so I don't have to rewrite the fraction 100 times. What we're going to do is notice that we have a common denominator, x and x plus h. So what we're going to do is multiply each fraction by what the other one is missing. So x plus h gets multiplied top and bottom by x gets multiplied top and bottom by x plus h. Then we can rewrite, and we have x minus x plus h in parentheses all over x plus h. I will then distribute that negative sign, x minus h all over x plus h. We can see these x's cross out, and finally we have negative h over x plus h as the final of the numerator. So we will plug that back into our equation of the definition of the derivative. Negative h over x times x plus h all over h. We see we have a fraction over a number. What we need to do is make this bottom denominator a fraction. We can see this is our main fraction right there, that fraction bar. So we put this guy over 1, and we will multiply by the reciprocal from top to bottom. Once we have done that, we can see those two cancel. This obviously cancels. And the limit as h approaches 0 of negative 1 over x plus h. So the whole key there was to cancel this h out, because if I plug 0 in there, it does not exist. We cannot have a 0 in the denominator. Now I have canceled that h out, and we can plug our 0 in, and we should be good to go. What we can tell is now we have negative 1 over x times x plus 0. That simplifies to negative 1 over x squared. And that will be your answer. So now that we have that function for the derivative, so f prime of x is equal to negative 1 over x squared, they're asking us to solve for f prime of 9. So all we need to do then is plug 9 in, and we are good to go. Negative 1 over 81. And that is going to be the final answer of the solution. So we found that derivative equation using the definition of the derivative, which is on the right side here. And then we plugged in our value 9, which is what they asked us to do. And we found that. So that is also the slope of the tangent line at the x equals 9. But that is for other videos for equation of the tangent line. Thank you. If you have any more questions, please send me an email.